Alright, this lesson deals with same side interior and same side exterior angles. Again, we're going to recap. So a transversal passes through two lines in the same plane at different points. Same side, in this case we're talking about the same side of the transversal, and the lines are always parallel for our purposes today. I know it feels like we might be beating a dead horse with some of these things, but since there is so much vocabulary throughout this unit, I want to make sure that we are keeping up. If at each of these review slides you're saying, yeah, I know this already, then that's a good thing. So, same side interior angles are two angles that are located on the same side of the transversal, and they are inside of the parallel lines. Just like with alternate interior and alternate exterior angles, that definition gives us a great idea about the location of those angles. We want to identify in the figure below same side interior angles. So we're looking first on the left hand side of the transversal, and in between the line M and the line N we see 3 and 5 that are same side interior angles. And then if we look on the right hand side, again on the inside, 4 and 6 are the two angles. We are given that the measure of angle 6 is equal to 65 degrees. So we want to find the measure of angle 4. So far, the supplementary angles that we have looked at have also been adjacent angles. Since 6 and 4 are not right next to each other sharing that common side, let's not assume anything yet. We can find the measure of angle 5 though, since they are a linear pair. They're adjacent and they're supplementary. So if we take 180 minus 65 degrees, that gives us that the measure of angle 5 is equal to 115. Angle 4 and angle 5 are alternate interior angles that we just learned about in the last lesson, and since the lines are parallel, we know they're congruent. So angle 4 is also 115 degrees. Does it hold that same side interior angles are supplementary? If the measure of angle 5 is 115 degrees and angle 3 is alternate interior with 6, then that equals 65 degrees. So the other pair of same side interior angles is also supplementary. We can assume that from now on, as long as the lines are parallel, same side interior angles will be supplementary. We will have some postulates and theorems to look at later that will show you this as well. With same side exterior angles, they're angles that are on the same side of the transversal but must be outside of the parallel lines. If we are given that the measure of angle 2 is 33 degrees, we want to find the same side exterior angle that is with angle 2 and also find its measure. So on the same side of this transversal, we come down and find that it's angle 8. We know that 2 and 7 are alternate exterior, so the measure of angle 7 equals 33 degrees. That plus the measure of angle 8 must equal 180 because they're a linear pair. Therefore, the measure of angle 8 is 147 degrees. It seems that same side exterior angles are also supplementary. Why don't we check with angle 1 and angle 7 to find out? Hopefully, in working this out, you figured out that angle 7 is equal to 33 degrees, so angle 2 is equal to 33 degrees, and angle 1 is equal to 147 degrees. So 1 and 7 are our same side exterior angles, and 33 plus 147 gives us 180. So the answer to our question is yes. Now we're going to put it together. So we want to find both the same side exterior angles and the same side interior angles here. If the measure of angle 4 is equal to 120, let's just go ahead and start by finding the same side interior angles. So we have 120 here, and the measure of angle 6 must add to equal 180. So 120 plus 60 is equal to 180. So the measure of angle 6 must be 60 degrees. The measure of angle 4 and the measure of angle 3 must also be 180. So the measure of angle 3 is also 60 degrees. We could have done that as well by remembering that alternate interior angles are congruent. The measure of angle 3 plus the measure of angle 5 must equal 180. So we determine that the measure of angle 5 is also equal to 120 degrees. Now we know all of the interior angle measures, and we can look at the exterior. 5 and 7 are supplementary, so 5 plus 7 must equal 180. 7 is equal to 60 degrees. So then we have the angle 1 up here, with it being same side exterior, those must add to be 180. So 1 is equal to 120 degrees. Then 1 plus 2 must also be 180. So 2 is equal to 60, and that makes 8 equal to 120 degrees. Again, here's the figure where we are given multiple transversals to try to throw us off, but we work everything exactly the same way. Here is one final practice for you. If the measure of angle 12 is equal to 60 degrees, we want to find the measure of angle 3 so that we can then find x. If we treat line AB as the transversal, this is an example like what I was talking about in the last lesson, where we're going to have to look at the picture flipped a little bit. So if AB is the transversal, then angle 3 and angle 12 right here are same side interior angles. That means that they must be supplementary. So this 60 degrees from angle 12 plus 2x minus 10 must equal 180. If we solve the equation, you should get that 2x is equal to 130, and that makes x equal to 65 degrees. So the measure of angle 3, if we plug 65 back in, would be equal to 120 degrees. So let's wrap up here by just reviewing what we've learned. If the lines are parallel, then same side interior angles are supplementary, and same side exterior angles are also supplementary. Your book uses the term same side, but others might call them consecutive. So don't let the terminology throw you off if you're looking at some different resources.